So, good morning, friends. This is Dr. P. Munaswamy, Professor, Department of ECE. Today, we can discuss the receivers part of the communication, especially unlock communication. So, before going to the receiver parts of the unlock communication, you can see what are the contents, what are the topics are available in this receiver part. So, here you can see mainly the types of the receivers. So there are tuned radio frequency receivers are there and super heterodyne receivers are there. These are the two main unlock type receivers which we are going to discuss in this module. So that is the TR of receivers stands for the tuned radio frequency receivers. Another one is the super heterodyne receivers. So under each and every receiver, we are going to have some important functional elements, blocks. So those are, one is the RF section, the frequency range, what is the frequency ranges we are going to take, and also tracking, how we are going to tune to the desired frequency, and IF, intermediate frequency, and AGC is there. AGC stands for automatic gain control. So based on our requirement, we can adjust the gain manually, or it may be based on the requirement, based on the signal strength available, the AGC can be adjusted. So that is the name itself indicates automatic gain control. Based on the requirement or based on the signal strength available, we can update, we can increase automatically the gain of the receiver. Then you can retrieve the original signal without any disturbance, or you regenerate the original signal without any disturbance. So that is the tracking elements, IF, intermediate frequency, and AGC is there, automatic gain control is there. So these are the basic elements. Then you can have the comparison between the different types of the receivers. We are going to have the FM receivers are there, AM receivers are there, and based on the modulation techniques, and also coming to the pulse modulation techniques. Instead of taking the continuous sinusoidal wave as a carrier signal, in case of the pulse modulation techniques, you can have the carrier as a group of pulses, or train of pulses can be act as a carrier signal, so that automatically the modulation is known as a pulse modulation techniques, where we are going to use the carrier signal, a train of pulses or group of the pulses can be act as a carrier signal, then it is known as a pulse modulation. We are going to have the different types, what we have discussed in last classes also. So there are three types of the modulation techniques are there when we are going to use the pulse, a group of pulse, a train of pulses as a carrier. That is the case of the pulse modulation. One is the pulse amplitude modulation, PAM. So that is the case we are going to have here. This is the pulse amplitude modulation. So then PWM, it is also known as a pulse width modulation, pulse duration modulation, or it is also known as a pulse time modulation. So here we are going to discuss the how we are going to generate the PAM signal, how we are going to generate the pulse width modulation signal, and also last one is the PPM, pulse position modulation. Both cases we got to discuss about the pulse position, pulse width modulation, pulse amplitude modulation. So that is the case of the generation as well as the demodulation. So that is the contents or topics available in this receiver model. So you know that the fundamental definition of the PAM, PWM, PPM. So what is the PAM, pulse amplitude modulation means? The amplitude of the carrier signal, pulse carrier signal can be varied according to the instantaneous value of the modulating signal. So that is known as a pulse amplitude modulation. Similarly, coming to the pulse width modulation, the width of the pulse carrier is varying according to the instantaneous value of the modulating signal. Then it is known as a pulse width modulation. Then PPM, pulse position modulation. Here we can have we are going to consider this is the one pulse completely. So this is known as a leading edge. So the leading edge means it is increasing from 0 to high level. So similarly, there is a downwards from high value to 0, it is a trailing edge. So increasing from low value to high value is known as a leading edge. Or downfalls, that is the high value to low value is known as a trailing edge. This is known trailing edge, this is known as a falling edge or trailing edge. So based on the position of this leading edge or trailing edge, the position of this edges, it may be leading edge or it may be trailing edge. So based on the instantaneous value or strength of the modulating signal, then it is known as a pulse position. So that means you know that continuous modulation, analog modulation. So there are three types of there. There we are going to have the AM modulation, amplitude modulation, frequency modulation, and phase modulation. So that is there we are going to consider the parameters or characteristics of the carrier signal, that is amplitude, frequency, and phase. If you are varying the amplitude of the carrier signal according to the instantaneous value of the modulating signal, then it is known as a amplitude modulation. So that is there we are going to consider one of the parameter, amplitude, frequency, and phase. If it is a change in the amplitude, it is amplitude modulation. If there is a change in the frequency, it is known as a frequency modulation. If there is a change in the phase, it is known as a phase modulation. Similarly, coming to this pulse modulation techniques, here we are going to consider the three parameters, three values, three characteristics of the carrier signal. One is the amplitude, pulse amplitude. Another one is the pulse width or duration or time. What is online time? This is the one completely, this is on time. Or it is also known as a width of the pulse. So that is if you are going to consider the amplitude, width, and the position. Position means it may be leading edge or trailing edge position. So that is based on that the selection we are going to consider the leading edge. Then it is known as a the position can be changed according to the instantaneous value of the modulating signal. So these are the different types of the modulation techniques and demodulation techniques. So coming to the receiver part, we are going to discuss about only the demodulation technique here. So and also what are the basic elements, that is the RF section is there, the frequency tracking, and the intermediate frequency how you are going to generate. IF amplifier is there, ACC is there. So these are some of the basic elements we are going to discuss in this model. Then coming to what are the basic requirements of any receiver. So we are taking the AM receiver, AM and demodulates by using the envelope detector, especially in case of the demodulation techniques, analog type. We are going to use the envelope detector. Similarly, coming to the FM frequency modulation, we are going to use the frequency discrimination method, or it is also another technique is there. Phase discrimination method is also there. So especially for this case, we are going to discuss the envelope detector. Another one is for the case of the frequency modulation, we are going to use the frequency discrimination method. So these are the techniques we are going to discuss for this receiver part. So here we are going to take the AM and FM only. So the AM modulation is over. After transmission, the same signal can be received at the receiver part by using the envelope detector. This is envelope detector, which can detect the modulated wave and convert the original signal. So that is one of the receiver part. Another one is FM. It is a frequency discrimination method. So based on the received frequency modulated wave by the method known as the frequency discrimination can be used to demodulate the original signal. Then coming to so you know that what are the basic elements or what are the types of the receivers. So already you have discussed the first slide, that the TRF receiver is there, tuned radio frequency. So according to the transmitted signal, the receiver part can be tuned by the use of the ganged capacitors, by tuning capacitors, you can reach the or allow the only transmitted or wanted signal. So even though there is a more number of signals with different frequency ranges are available in the space, so because of the tuning part in our TRF receiver, which can tune to the desired frequency and rejects the unwanted signals available in the space. So that means the filter can be act as a filtering which can allows the only wanted signals, desired frequency signals only. So remaining will be rejected. So that is the tuned radio frequency receiver's main function. So that is a regenerative receivers are there. So another one is a super heterodyne receiver. You know that. So here super heterodyne means, what is the meaning of the heterodyne means? Mixing of the two signals. Heterodyning means mixing of the two signals by the operation of the addition or subtraction. We can generate the IF frequency, intermediate frequency. So that is the main purpose of the super heterodyne receiver. So even though our received signal is more in terms of megahertz, that signal can be converted to the IF value by the heterodyning operation, that is known as it may be addition operation or subtraction. So it can receive the two signals. One is from the space, which is modulated wave, transmitted wave. Another one is the locally generated carrier frequency. So by mixing operation, it may be addition operation or it may be subtraction. It can generate the mixer as a IF value, intermediate frequency value. So that is the main principle of the super heterodyne receiver. So in case of the TRF, tuned radio frequency, the ganged capacitors are there. By tuning those capacitors, we can tune to the desired frequency and rejects the unwanted other frequency components available in the space. That is the main purpose or function of the TRF receiver. Whereas in case of the super heterodyne receiver, here we are taking the mixing operation. So there is a basic element of the any super heterodyne receiver is mixing operation. Mixer is there, which can perform the operation of the mixing. Then coming to the tuned radio frequency receiver is one of in which the tuning or selectivity is very important. So even though there is several frequency components are there, that based on the requirement, we can arrange the capacitors tuning such that which can tune the desired frequency only. So that is the main what happened in the TRF receiver. So that is the tuning is provided with the tuned coils or capacitor combination, and then signal is presented to a small crystal or diode detector where the signal can be recovered. So that is the main purpose of the TRF receivers. So there is an arrangement of the ganged capacitors are there. You can see the diagram. You can easily understand what is the how we are going to take this TRF receiver. So here, so this is the antenna. So by the support of the antenna, we can select the desired frequency, and then is given to the first stage of the RF amplifier. The received signal, the antenna can be act as a filter or sensitive to the desired frequency components only. Those can be selected by the antenna, and then immediately the received frequency components are in RF range, radio frequency range. Those signal can be amplified by the first RF amplifier. Is the sufficient energy improved or amplified, then immediately there is no need of second arrangement of the second RF amplifier. See, is there any insufficient? The amplified signal strength is not reached to the desired value or sufficient value. Then you can arrange the second RF amplifier. So the first one is the antenna received the signal. So then here we can see the ganged capacitors are there. So the ganged capacitor, what is the purpose of the ganged? All the ganged capacitor are connected to the first stage, second stage and the detector. So here with the support of this ganged capacitors, we can tune to the desired value. So that is the main purpose, main function of the tuned radio frequency receivers, TRF receivers. So by the ganged capacitors, we can tuning to the desired value. Once the selection is over, the received signal is obtained to the desired frequency. Then immediately, to increase the strength of the received signal of RF, we have to arrange one or more or one or two radio frequency amplifiers, which can increase the strength of this received signal. So once you have the amplification is over and first and second stages, then you can go for the detector. So the function of the detector is which can make the operation of the demodulation. So the received signal modulated wave, which is a combination of the carrier signal as well as the modulating signal. Here our aim is by the support of the detector, we can detect the only modulating signal, which is our original signal, which is transmitted at a transmitter side. So that means by the operation of the detector, we can eliminate the amplifier carrier signal and obtain the only modulating signal, M of t. So once the modulating signal is detected, the modulating signal can be available original information that can be given to the audio amplifier. So because once you have the detection is over, so suppose you take the example AM modulation is there. So for this case, what you have discussed in the first slide, for the case of the AM demodulation, we are going to have the two demodulation techniques. So especially in this case, we are taking the square law detector or envelope detector is there. So for this case, we are discussing the envelope detector, which can detect the envelopes, tops of the modulated wave, that is converted into the original modulating range, audio frequency range. So that can be given to the audio frequency amplifier. So that is, once you have the demodulation or detection is over, the received signal is available in the audio frequency range. That is the audio frequency range. So that we have to arrange this audio amplifier for increasing strength of the modulating signal. So is there any weak? The signal strength is very weak. Then you can go for the audio frequency amplifier, which can increase the strength of the modulating signal. So whereas first case, here we have to arrange RF amplifier. So what is the difference? The received signal is modulated wave, which is available in the radio frequency range. So that we have to arrange a RF amplifier here. Once you have the detection is over, the RF range can be converted into audio frequency range. So that you have to arrange the audio amplifier, audio frequency range amplifiers only after the detection, after the demodulation. So once you have the audio frequency, audio amplifier is over, that is given to the another amplifier is known as a power amplifier. So which can increase the power of the audio frequency range, demodulated signal wave. So once you have the power amplifier over, then you can go for the generation of the original signal, that is sound signal with the speaker. So here at the beginning, transmitter side, we have to use the transducer, which can convert the non-electrical quantities, that is sound signal or voice signal, into the electrical. At final, coming to the receiver part, after the amplification of the audio and power amplifier, then we are going to use the another transducer, which can convert the electrical energy into the sound signal, physical signal. So that is the purpose of the speaker here. The speaker is a best example for the transducer, which can convert the electrical signal, that is the audio signal, audio frequency modulating signal, and finally generates the sound signal. So this is the overall, the entire operation of the TRF. So you can take the why it is a tuned radio frequency. Every stage you take the antenna from the beginning, first and second and detector, there is a tuning operation is there. So by the support of the gang capacitor, we are taking the tuning operation, so that it is a tuned radio frequency receivers. Once detection is over, there is no need of again tuning. The desired audio frequency range or modulating signal is detected, that can be amplified by the audio and the power amplifier, finally generating the sound signal with the speaker. Then coming to these are the complete operation what you have discussed in the previous slide also. So there are several stages as RF amplifier is there, first and second stages are there. The amplifier, audio and frequency power amplifiers are there. Finally, we have to, after amplification, we are generating the sound signal with the support of the speaker. That is operation here. So the basic super heterodyne receiver. So until the super TRF receivers, there is an arrangement of the tuning capacitors. Gang capacitors is somewhat difficult. So to overcome those problems, we can go for the another super heterodyne receiver. Another receiver type is known as a super heterodyne receiver. So here the basic operation, the basic concept and the theory behind the super heterodyne receiver is, which involves the operation of the or process of the mixing. So mixer is a very, very important role in case of the super heterodyne receiver. So why? Because with the support of the mixer only, we can generate the IF value, intermediate frequency. So even the received signal frequency in terms of megahertz, giga, with the support of the local oscillator frequency, both input signals received from the space, that is modulated wave, which is available in the mega range, mega frequency range, and also locally generated carrier signal in terms of the kilo or mega. So by the mixer, by mixing the both input signals and take the operation of the addition or subtraction, we can generate the IF value. Finally, the mixer output is always IF value only. So this is the mixer or frequency changer, or it is also known as converter. So overall, whatever the signal received from the space, that is modulated wave and locally generated carrier signal, by the mixing operation, we are changing into the IF value, so that it is also known as a mixer, which can mix the two input signal and generate the IF value. It is also known as a frequency changer. IF value, high frequency RF radio frequency range to IF value changing, so that is the frequency changer, or converter. So radio frequency range to IF value conversion is taken, so that is also known as a converter. So mixer, frequency changer, or it is also known as a converter. So this is the mixing operation. So with the support of the circuit diagram here, you can see that we are going to have the RF value here. So here we are going to take the mixer file. This is a mixer. Then we are going to get the local oscillator IFT, intermediate frequency 1. And then there are separately excited mixer gang capacitors are there. All the capacitors are there. This makes the operation of the tuning. So finally, we are going to have the operation of mixing with the support of this circuit. So it's a combination of the FET and transistors, local oscillator. So this is the local oscillator. One is getting from the another RF received modulated wave. These two local oscillated signal and the RF value given to the mixer. This is the mixer operation. Okay, completely. So this is about the mixer diagram. Then tracking, we are going to have the trimmer tracking, 3-point tracking, a padded tracking. So that is tracking means without error, the received signal frequency can be tracked to the desired value. There are three commonly used tracking methods are there. One is a padded tracking, trimmer tracking, another one is the 3-point tracking. These three are there. So this is the intermediate frequency generation circuit diagram. You can see the first stage IF amplifier and the second stage IF amplifier. So once you have the operation of the mixing, so there we are going to input RF signal and the locally generated carrier signal. Both signals are given to the mixer. The mixer output is getting is IF value, intermediate frequency. So for increasing strength of the IF value, we are going to arrange these two types of the two stages of the IF amplifiers. The first stage IF amplifier and second stage IF amplifier. You know that how we are going to reconstruct build the IF amplifier with the support of the resistor, inductor and the transistor. This is the circuit diagram for the intermediate frequency IF amplifiers. So you know that automatic gain control. So here the received signal strength is very weak. The automatically the gain can be increased to retrieve the original signal without any loss, without any disturbance. So there are two types of the AGC circuits are there. One is the simple AGC, another one is the delayed AGC. So there are two types. One is the simple AGC, another one is the delayed automatic gain control. So this is simple AGC, where we are going to have the detector diode and finally add amplifier and speaker sound generation. So with the support of this one, you can increase the strength of the modulating signal. So that indicates without any disturbance, without any loss, we can regenerate, reconstruct the original signal. That is a sound signal here. This is delayed. So there is some threshold adjustment is there. So based on that, we are going to have the delayed AGC. This additional component we are going to get the externally compared to the simple AGC. So there is a delayed AGC circuit is there. These are the comparison. You know that what is the difference between the AM and FM. So based on the properties of the carrier signal, we are going to change the amplitude of the carrier signal according to the modulated signal strength. It is AM modulation. If there is a change in frequency, it is a frequency modulation. So there are several methods are there for generation of the AM signal and FM signal. Similarly, the same demodulation techniques are used in case of the receiver's part. So the method audio transmission was first successfully carried out in the 1870 in case of the AM modulation. So here 1930 we have take the FM radio receivers. So these are the originally initially we are going to take the receiver part. So that is based on what is the technology modulation technique used at the transmitter side. The same demodulation technique. If it is AM, we are going to have the AM demodulation. If the modulation is FM, it is a FM demodulation technique. In case of the FM demodulation, what we discussed, there is a frequency discrimination method is there and the phase discrimination. Here AM, we are going to have the square law detector and analog detectors are there. There are several types are there. So zero crossing in case of the AM modulation technique. There is no need of FM here. So complexity, you can see that bandwidth requirement AM, it is a 2 FM only. So FM, it is infinite theoretically, but based on the Carson rule, it will be limited to 2 delta FM. So that is 75 delta FM. 15 kHz is a bandwidth deviation. So we will get the according to the Carson rule, you can define what is the bandwidth requirement for the FM. So this is the superintendent receiver. So which is the receiving antenna and the RF amplifier is there. And then there is a mixer is there. So mixer will get the one input from the RF value, another input from the local oscillator. Both the IF value will get the intermediate frequency difference of these two. And there is a multiples of the IF amplifier. It can increase the strength of the IF signal. And then there is a AGC is there, automatic gain control, automatic frequency control. So that is based on that you can increase the gain, and then demodulation is there. Once you have the demodulation is over, then we are going to have the low pass filter which can increase allows the only audio frequency range signal, and there is an amplifier audio frequency power amplifier. Finally, you are going to get the sound signal. So this is about the overall TRF receiver and superintendent receiver. RF 200 section is there, which can used as a tank circuit. So it is a combination of the L and C. With the support of the L and C, by making one of the component as a variable, we can do the desired frequency value of RF. So this is the RF section and circuit diagrams. Mixer and changer converter is there. So already I discussed.
Like, share and subscribe. Hit the bell icon for more updates.